Let's interface a switch with the 8051. Pressing the button lights up the LED. The code monitors the voltage change at the pin. Perfect switch interfacing. A push-button switch is one of the most commonly used digital input devices in embedded systems. The microcontroller reads the switch state as a binary input represented by logic 1 or logic 0. An unconnected input pin may float between logic levels, causing unpredictable behavior and false readings.
A pull-up resistor keeps the input at a stable logic high level when the switch is not pressed.
With a pull-up resistor, the input remains high when released and becomes low when the switch is pressed. A pull-down resistor provides the opposite configuration by maintaining a default low state. In a pull-down configuration, the input remains low until the switch is pressed. Both pull-up and pull-down resistors eliminate floating inputs and provide reliable digital signals. Mechanical switch contacts do not settle instantly and may bounce several times before stabilizing. These unwanted transitions can be interpreted as multiple button presses by the microcontroller. Software debouncing introduces a short delay to ensure only one valid switch press is detected.
The switch acts as the input device, while the RGB LED acts as the output device, controlled by the microcontroller. An RGB LED contains 3 individual LEDs that can be controlled separately to generate different colors.
The program reads the switch input and controls the RGB LED outputs connected to port P2.
The firmware initializes the ports, checks the switch state, applies debouncing, and controls the LED outputs.
This project demonstrated switch interfacing, pull-up and pull-down resistor concepts, software debouncing, and RGB LED control using embedded C on the 8051 microcontroller. Thank you for watching.